Hi, this is Mr. Manley. In this video, we're going to look at finding the determinant of a matrix. So maybe in previous videos you found an inverse of a matrix. This is the determinant. This here is determinant notation. So I would say, like, just a few notation issues here. Like I might have matrix A is equal to this matrix, this 2 by 2 matrix, and then I might say I want the determinant. So I could go like this, and then kind of what looks like absolute value bars, and then that's going to be applied to the matrix above. So that absolute value sort of notation is being applied here, which is implying that we are being asked to find a determinant just by the notation. So that's one thing about this. Just a comment here. You might recall with inverse, we had to have a square matrix in order to find an inverse. Same with determinant. So for a determinant, we have to have a square matrix, have to have the same number of rows and columns in order to be able to find the determinant of a matrix. Something that I talked about with inverse, I set a little bit of context and talked about it in relation to a kind of idea of division for matrices, or a stand-in for division. So what is determinant? I really don't have an answer for that. The determinant, I like to say, is whatever it does. And there are lots of different things that a determinant can do. We will see one of them in a later video. For right now, let's just look at finding the determinant, which is, it seems a little bit curious what this is, not knowing what it does and why would we do this. But I think that you will recognize something about it right off the bat in regards to inverse. So the determinant of this matrix is this: 6 times -6 minus -6 times -4. Well, does that look familiar? I think it might if you think about finding the inverse of a matrix. So let's say that this is -36. So that's -36 minus 24. And the determinant is -60. And that's it. That's the answer. It's simple as that. Let's do one thing. Let's just look at the general form of the determinant. And remember, this is only for a 2 by 2 matrix. The general form of the determinant of a 2 by 2 matrix, ABCD, would be equal to AD minus BC. Again, doesn't that look familiar? And now if I take this matrix A, if I take this determinant and I said, I've got a matrix A here that is based upon the numbers that are in this determinant. So I say I've got that matrix A, and then here I found the determinant of matrix A. Well, what if I said this? What if I said I'm going to find the inverse of matrix A? And what would I do? I would do 1 over, and I would do 6 times -6 minus -6 times -4. Well, how about that? That is matching this. So if you go back to your notes on finding the inverse of a 2 by 2 matrix, and you see the general equation that you were given, that an inverse of a 2 by 2 is equal to 1 over AD minus BC, and then we had that business with how we rearranged the elements of the matrix. Well, this part here, I could rewrite it now, right? So we were calling it AD minus BC. I could rewrite it to this. I could say that the inverse of a matrix, of a 2 by 2 matrix, is equal to 1 over the determinant of that matrix. So there is something that a determinant is used for. It is used to find the inverse of a 2 by 2 matrix. And that is just one of many applications of determinant. Like I say, the determinant is whatever it does. And in this case, what it does is it finds the inverse. But there are other things that it can do as well. So that's it for a 2x2. This only works for a 2x2, this method. And in another video, we'll take a look at how we find the determinant of a 3x3. And in yet another video, we'll look at another application of determinants where they will do something for us.